We're looking at Collingwood's Precalculus text. This is the University of Washington's Math 120 textbook, and we're looking at Chapter 2. Chapter 2 asks us to look in depth at the idea of a coordinate system. So let's first ask the question, what is a coordinate system for? Here's a point. I've drawn it on the plane on my board here. A coordinate system is for clearly and concisely and specifically identifying a point. In particular, it gives us a way to compare points, to give a mathematical notation for points in the plane. We take our plane, which is drawn here, it's blank initially, and we impose a coordinate system on our plane. What does this actually mean? Imposing a coordinate system is to impose some sort of reference system. So the most common coordinate system, the one that you've all worked with extensively, is this one. We draw a vertical line, which we call a vertical axis, and a horizontal line, which we call a horizontal axis. Generally, we denote this as the x-axis and the y-axis. This point here where the x-axis and the y-axis meet is referred to as the origin. So how does drawing these lines help us to specify this point? Well, in order to introduce a numerical notation for this point, what we'll do is we'll draw a line that's parallel to the y-axis, and notice that it hits the x-axis in specifically one point. And we'll draw a line parallel to the x-axis that goes through our point in question. And notice similarly that it hits the y-axis in exactly one point. So given this point, which we might call P, we draw a vertical line which intersects the x-axis at some point, which we might call A, and intersects the y-axis at some point, which we might call B. On this x-axis, I'm imagining that there are a bunch of little notches. And on this y-axis, similarly, I'm imagining that there are a bunch of little notches. And I can simply count the notches. Counting to the left, I would label with negatives. And now I can specify my point by writing it as A comma B with parentheses around it. In this particular case, my point is 4, 3. Now, there's a few key things to keep in mind here. First of all, although Collingwood begins section 2.1 with the title, The Coordinate System, I want to point out that this is a coordinate system. How could we make this coordinate system different? Well, what choices did we make in imposing this coordinate system? First of all, we chose where our x-axis and our y-axis intersected. We could have chosen to have our origin anywhere we want. We also chose to make these units count quite simply 1, 2, 3, 4, 5, 6. And these units 1, 2, 3, 4, 5, 6 to also count quite cleanly. And notice that the gaps between notches here is about the same as the gaps between notches here. So we could play around with our coordinate system by changing where we put the origin, or by changing the scale of either the x-axis or the y-axis or both. Or we could make some more radical changes, which in this video we won't consider, but I'll just mention them here. We could try, instead of having our x-axis scale 1, 2, 3, 4, 5, 6, maybe we could try having our x-axis scale a little bit more strangely, say 1, 10, 100, 1,000, 10,000. Or maybe a little bit more nicely would be 1, 10, 100, 1,000, 10,000. That would be weird. We could try it. We could also keep the labels on the axes the same, but instead drop our insistence that the axes be perpendicular. Also would be a little bit weird. Either of these do give coordinate systems, and they do give coordinate systems that are useful in different contexts. So in precalculus, we'll primarily be studying this standard coordinate system, sometimes called the Cartesian coordinate system or a rectangular coordinate system, but we'll consider some stranger coordinate systems in order to make sure that we have a really flexible understanding of these coordinate systems.